We are going to be looking at domain and range for quadratic functions. Before we do that, we're going to go ahead and just talk about what domain and range are. So just to review, domain is the set of all possible inputs or x values. If you notice, domain ends in in, inputs begins with in, right? So when we think about inputs and outputs, we think of x and y. So domain is just x, right? So if you see a graph, just look for the x. That's where we're going to start. We read the domain just like we read the x-axis, from left to right. Another way to think about that is from least to greatest, right? So it's just like reading a book, from left to right. That's the domain. So if domain is x's, range is the y's. So what comes before outputs, inputs, right? X comes before y. So when we talk about range, we're just talking about what's coming out. When we focus on the y-axis on a graph, right, we're going to do that by reading the range from bottom to top, so bottom values to top values, or you could also look for the least and then the greatest, right? So we're just looking for the least y all the way up to the greatest y. So let's see what this actually looks like. Let's just focus on domain first. So this question says, what is the domain of the quadratic function shown below? So we see a quadratic function, it's positive going up. The first thing we're going to do is focus on that x, right? So domain is x, and we're going to read that x-axis. So we go from left to right. Once we do that, we're just going to read the graph. So we're going to start on the left side of the graph, and we see an arrow, and then we're going to move all the way down, and we're going to actually move to the right side of the graph. So when I focus on the left side of the graph, you can see here, that arrow essentially just means it's going to go to the left forever. So numbers just keep going forever. And what do numbers do as you move to the left? They get smaller or they go down. So we can represent that using a negative infinity. So negative infinity is our bottom border or our left border, whereas you move to the greatest side and we have an arrow that goes on forever. So on the right side, we would express that as positive infinity. So x is always going to be between negative infinity and positive infinity, right? So instead of saying that, we would just say x could be all real numbers. So the domain is x can be anything, because if you look on the graph, right, these arrows here and these arrows here mean that x could represent anything on this function, right? Whereas if we focus now on the range, so notice the graph stays the same, the domain stays the same. We just want to now find the range. So we're going to look from bottom to top, right? So the first thing you do is you see range, you think of y's. And we read y's up and down. So we go from bottom to top. So the bottom of our graph is where that little dip is. And it looks like it's between 5 and 6, negative. So that would be negative 5.5 negative is less than or equal to y. So this is just like our bottom border. And then the top, we notice that there's arrows going up forever. So we just say y can be less than or equal to infinity. Well, is 1 less than equal to infinity? Yes. Is 1,000 less than or equal to infinity? Yes. We don't need to say like it's less than infinity, right? That doesn't really make a whole lot of sense. So instead we would just take that off. So you could say negative 5.5 is less than or equal to y, or y is greater than or equal to negative 5.5. So it just has like a bottom border, but there's nothing stopping it on the top. It goes on forever. So let's just look at like a positive function versus a negative function. You would go through the same steps. You would start from the left, move to the right, and that would tell you your domain, right? We wouldn't write it like that, where we say x is somewhere between negative infinity and positive infinity. Instead, we would just say x could be all real numbers. So that's our domain for a positive function. And for a negative, it would be very similar. From left to right, the numbers are going on forever. So instead of writing it out with infinity symbols, you would just say the domain could be anything, all real numbers. The range, we'd start from the bottom on the positive function. We would notice that dip at negative 9, right? So negative 9 is our bottom border. And then watch what happens at the top here. So that left and right border from before, we're still focused on those same arrows. It just now represents the top. And so those arrows are both going up forever, which just means y is going to be somewhere between -9 and infinity. We don't need to say a number is smaller than infinity, so we could just say that y is greater than or equal to -9. So just when you flip the y and the -9, that symbol switches. So just kind of notice the difference there. For a negative function, just watch what happens. So remember what we just did? Instead of starting now at the bottom over here, right? The bottom over here looks a little bit different because there's arrows here. So instead of starting with a number, we're starting with infinity, right? And that should actually say -infinity. So just pretend that says -infinity. I'm not going to change it at this point. But if we look at the top, right, there is a top border. So that curve stops at 8. So we just say that y is less than or equal to 8. We don't want to say that y is basically bigger than -infinity. So instead, we're just going to basically say y is less than or equal to 8. So the -infinity there, and actually I think, let's just mark this up so I don't feel crazy. So that should say -infinity. So we don't want to represent that because it's obvious, right? Y is always going to be going down. So as long as we represent the top border, y is less than or equal to 8, you have this function covered. That's the range. Looking at just at an example problem, right? So you see that this represents a golfer's ball that he hits, or she. So in this situation, I just want you to focus on the key information, right? So we got 3 points, and from these 3 points, you need to figure out what's the domain. So we go from left to right, and you're just going to focus on the x values. So 0 to 30, right? 0 is less than or equal to x, which is less than or 230. So all that means is that x can be anything between 0 and 230. What about the range? Well, instead of focusing on left to right, we're going to go from bottom to top. And the only twist here is it looks like there's 2 bottoms, but only one of these can actually be a bottom, right? So which one is lower? So is the left point lower or the right point lower? Is 6 lower or is 0 lower? So we would actually say that the range could go from the bottom, which is 0, all the way up to the top, which is 36. That means that this, we don't actually need it because it's not a true bottom, right? So we're just going to focus on the lower number. If you understand that, then I feel like this is a reasonable expectation. Could you figure out the domain and the range for this? And all you really need is the same 3 pieces of information we needed before. So focus on the arrows that go on forever, and then focus on the bottom here, in this case, so that we would call that the vertex. But from this information, could you find the domain and the range? Good luck.